Welcome to the video tutorials of mechanisms by Mechanismuller. A ram pump is an interesting device for pumping water to high elevation without using any external power unit. The catch is the location. If you live somewhere near a creek where water is flowing downhill, then you are in luck. This is prime location as far as operating a ram pump goes. The simulation shown here how the ram pumps work, but how it works and seems to discard so much water needs explanation. Ram pumps use the potential energy of flowing water to pump the water to a higher elevation. To understand this concept, let's look at the following drawing. As you can see, 10 liters of water with a water head of 10 meters has the same potential energy as 1 liter of water, with a water head of 100 meters. The potential energy for both is approximately 1 joules. Assuming we have 100% efficiency, this means that water flow of 10 liters per second at a 10-meter drop has enough potential energy to pump 1 liter of water per second up 100 meters. Now imagine that we do not know anything about ram pumps, and want to pump water to higher elevation using nothing but the power of water itself. This would be easy if we had a water turbine and a conventional pump. As you can see in the second drawing, we can take the large volume of water from the low water head, and feed the turbine with this water. A small portion of this water is being fed to the pump, while we are disposing a large quantity of the water to the environment. Some of you may be asking about the pump and turbine efficiencies. If both the pump and the turbine are 90% efficient, we would not be able to pump 1 liter per second, but something closer to 0.8 liters of water per second, for 100 meters of elevation. If there was not ram pump, this is most probably how we would handle this. Now we know that are able to pump water to higher elevation by using nothing but the potential energy of water. The problem with this solution is that it is both expensive and complicated. We first convert the power of water to mechanical power, feed this mechanical power to the pump, and then the pump converts this mechanical power to potential energy, by pumping the water to higher elevation. In this process 9.2 liters of water are disposed to the environment per second, and 0.8 liters of water are pumped to higher elevation. Ram pumps are able to do the same thing simply by using an elegant design. Here is how this ingenious mechanism works. The water flowing from higher elevation is fed to the ram pump through inlet pipes. Since the waste valve is initially open, the water begins to flow outward at high speeds and is discarded to the environment. This causes the pressure around the waste valve to drop and shuts it quickly. The weight of the total water in the inlet pipes may be as much as a grown man, or even more. Imagine this heavy man running as fast as the fastest man, and then suddenly hitting a concrete wall at that high speed. This is exactly what happens to the water when the waste valve is suddenly shut. This then causes the pressure within the inlet pipe to increase as seen here with the color red. You may have observed this phenomenon in your life. When you shut your water faucet very suddenly, you hear a loud noise in the pipes of your home. It's much like that but on a larger scale. Now let's go back to our discussion. The increased water pressure within the pipes must be relieved to prevent damage to the system. This is done by the delivery valve. The high pressure in the inlet pipes opens the delivery valve, which directs the pressurized water to the accumulator compartment, and the delivery pipe at the same time. While the water level is rising inside the accumulator, the air pressure trapped above increases. Sometime later, the water closest to the waste water valve moves backwards toward the accumulator, causing the waste valve to open, and cycle repeats itself all over again. When the waste water valve opens, the delivery valve closes and vice versa. However, the water continues to flow through the delivery pipe and this is due to the pressure of trapped air inside the accumulator. The accumulator acts just like a flywheel and regulates the water flow rate through the delivery pipe, and takes pressure spikes from the system. The system may seem like it's disposing too much water, but it's not the inefficiency of the ram pump, but instead the requirement of the conservation energy principle. If 10 liters of water per second is fed to the ram pump, and 2 liters of water per second would pump to 100 meters of elevation, this would violate the conservation energy principles. But a quarter liter per second is a darn good flow rate for the system mentioned, and does not violate any energy principles. Thank you for taking the time to watch our video. If you enjoyed this video and found it to be useful, please subscribe to my channel and hit the like button. We appreciate your support.